let's do this. So guys, lesson 3 is on domain and range. You should have at least have heard these terms before. Our essential question is, how do you identify domain and range from a graph? So first let me give you some vocabulary of before we can even talk about domain and range, we have to define what a relation is. So a relation is a pairing of elements in the domain to elements in the range. Basically, any coordinate, x, comma, y, that you ever see on a graph, on a list, from an equation, that is a relation. Okay, so if there is an x and a y that can be written as a coordinate, it's part of a relation. So I'm actually going to write that. When I say a pairing of elements, I mean x, comma, y. Okay? The domain are all of the inputs in the relation. And another word for input is your x values. So our x values, or what we plug in, is your domain. On a graph, it is along the x-axis, right? Left and right is your domain. And so the range then is all of the outputs in the relation. So all of those y values. So your domain are the x values and your range are the y values. So all of last week we were talking about different function families. So we threw the word function around a lot. All functions are relations, but not all relations are functions. So then the question is, how do we decide if something is a function? So let me give you guys the definition of that one. So the definition of a function is a relation where each input has only one matching output. And I wrote only one in all caps, and I'm also going to triple underline it. That is super important. So a relation is only a function if every input, every x value, is matched up to only one y value. And I will tell you what I mean after you write the full definition. We'll do an example. So then the question is, how do you determine if a relation is a function? So with our Cornell notes, remember each section should have a question that the right-hand side answers. So on the left there's a question, on the right we actually answer it. Most of our notes so far have just been terms. So the term is on the left and the definition is on the right. So how do we determine if a relation is a function? We can look at the coordinates, so the points, and we can also look at the graph. So let's talk about the points first. If we are looking at the points, you are first going to look at all of the x values. So when we're talking about a function, we really only care about the domain, which is the x values. If an x value is repeated, check to see that it is matched up with the same y value each time, and then it is a function. Okay, so if I list the point 1, 2, and then I happen to list the point 1, 2 again, it's still a function because the y value is the same. If it is matched up with different y values, it is not a function. So for this first example, I'm giving you two different sets of points. So the left is one set and the right is a second set. Okay, so these are two different examples. These sets are in curly brackets because when we are listing coordinates, we want to put them in curly brackets to show that they all go together. So curly bracket actually means a relation. So these are all relations because they have x's and y's attached to each other. So in this first set, I have the point 1, 2. I have the point 3, 5. I have the point 1, 4. And I have the point 3, 6. So here's what I'm going to do. With functions, I'm going to say it a million times, we are really only concerned about the domain. So first, let's see if we can list the elements in the domain. Can somebody give me one element in the domain? Jonah.
3.
3 is an element in the domain. And actually, how many times does 3 show up? Twice, here and here. So if on a question I ask you to list the domain, you would list the number 3. And then what other domain value would we list? Kiki. 1. And 1 actually shows up multiple times too, right guys? How many times does 1 show up? Twice. Here and here. Okay. Now, if an element in the domain is repeated, we only have to list it once. So our domain actually only has 2 elements, 1 and 3. Does that make sense? So you don't have to list the 1 and the 3 multiple times, just once. So let's look at our definition above. How do you determine if this is a function? It says we check all the x values. So we did. We have x value 1, 3, 1, 3. If it is repeated, it has to be with the same y value. So let's look at our 1s. The first one is attached to a what?
2.
A 2. And the second one is attached to a 4. Is it the same y value?
No.
Okay. So is this a function?
No.
No. Even if they were the same y value, our 3's are both attached to a 5 and a 6. So they are also not a function. Does that make sense? So this whole thing on all different levels is not a function. So we would write not a function. Okay. And if I ask for an explanation, you would say because an x value is repeated, or because the x value 1 is attached to 2 different y's, and the x value 3 is attached to 2 different y's, something like that. Okay. So let's look at our second set. It contains the points 0, 2, 1, negative 3, 5, negative 4, and 0, 2. What I would like you to do is turn to your neighbor, list the elements of the domain. So tell your neighbor what the elements of the domain are. Okay, so who wants to tell me the elements of the domain? Somebody who has not gone yet. Christian. 0. What else? Is 2 in the domain? No. What's another element in the domain? Go ahead. 1. What else? 5. And 0. Do we have to list 0 more than once? No. So if I asked you what is the domain, you would list 1, 0, 1, 5. That's it. That's all I'm asking for. Does that make sense? Okay, so then we want to know, is this a function? Look at all of our domain elements. Are any of them repeated?
0.
0 is repeated, but look at the y that it's attached to both times. Is it the same?
Yes.
Yeah. So is this a function? Yeah, so this one is a function. Most of the time, you guys, a point will not be repeated. But I wanted to put an example just to show you what happens if it is. So most of the time, 0, 2 will not show up multiple times. Okay? So usually it will be just one of each domain element unless it's repeated like in example 1. Okay? So the left is not a function because the elements in the domain are attached to multiple range elements. And the right one is a function because each element in the domain has only one y value attached to it. Sound good? Okay, so there are different ways of representing relations as well. So let me pull this up. We call this a mapping. So you can also represent a relation in terms of a mapping. Always when we are mapping, the left side is your domain and the right side is your range. So I'm going to write that. So you always, when you have a map, unless it's indicated otherwise, the left is your domain and the right is your range. Oops. And the arrows just indicate which elements each one maps to. So on this one, 4 maps to 1. If I was to write that as a coordinate, it would be 4, 1. Does that make sense? So the left are your x's, the right are your y's. So I would, what I'd like you to do is write both mappings, and then we're going to talk about how we can tell if they're functions or not. So how do I determine if one of these mappings represents a function? It's the exact same thing. The x value cannot map to more than one y value. So let's look at 4. Is 4 mapped to only one y value? Yeah, to 1. What about 5? Is 5 mapped to only 1? Yes, 3. 6 doesn't map to anything. Don't ask me why. And then 7. Does 7 map to more than one y value?
Yes.
Yeah, it goes to 8 and to 2, which means that the point 7, 8 is on our graph and 7, 2 is on our graph. So is the left a function?
Yes. Yes.
Read your definition again. If it maps to more than one y value, it is not a function. So is the left a function? No, not a function. I'm going to run out of room, so I'm going to say not a func. Okay? So then let's look at the right-hand side. I have 4 domain values. My domain consists of -2, -7, -1, and 0. -2 maps to 4. Does it only map to one value? -7 also maps to 4. Is that okay? Yeah, because in a function, we only care about the domain. That's it. Ooh, that one was really dark. Let me just go once. In a function, we only care about the domain. So as long as the domain only maps to 1, it doesn't matter if 2 x's share a y. Okay? So it doesn't matter if 2 x's share a y as long as each domain or each x has only one y. So -2 goes to 4 and -7 goes to 4. They each only have one line coming out of them, right? So we're still good. -1 goes to 2 and 0 goes to 2. They each only have one line coming out of them, right? So is this one a function? Yes. So this one is a function. Does this make sense? Okay. We'll look at how to do this graphically. I have one more example from points. And this is going to be from a table. So from a table, you guys should be very familiar with the table, right? Here are your x values or your domain. So I'm going to write that. Your x values is your domain. Your y values are your range. A mapping is very similar to a table, right? So my domain consists of 2, 3, 3, 4. Or I could just say it 2, 3, 4. And my range has the elements 5, 8, 9, and 10. So what I want you guys to do is talk to your neighbor. I'm going to give you about 30 seconds. See if you and your neighbor, you guys will be a group of 3. See if you guys can figure out if this one is a function or not. So I'm going to have you try this one on your own. Go. So this is not a function because an x is repeated twice with different y values. Which x is repeated? 3. And they have different y's, right? So not a function. Okay? As long as you can put that into words in some way, you are good. So we should be clear from points, right? Let's do it from a graph. And from a graph, it's actually way easier to determine if something is a function because we are going to use what is called the vertical line test. So from the graph, we're going to use the vertical line test, meaning you take your imaginary line and run it across your graph from left to right. If the vertical line is ever touching more than once, at the same time, it is not a function. If at any given time it is only touching the graph once, it is a function. So you have 4 examples. Just do little sketches. They don't have to be perfect replicas of what I have. It's just so that we can practice. And you have some examples of ones that are functions and ones that are not. So I'm going to do the line with you guys first, and then I'm going to do the one right below it, and I'm going to let you do these squiggly lines with your partner. So vertical line test. We take our vertical line. I usually use my pencil, and I drag it across my graph from left to right. This one shouldn't be too bad. If my vertical line, which extends forever, is being dragged across my graph, does it ever touch the graph more than once?
No.
So is that a function? Yes. So this one is a function. I'm going to write yes. Okay, it is a function. That should be pretty apparent because we've been looking at these all last week. This is what type of function? A linear function. So let's look at the one right below it, this guy right here. As I'm dragging my vertical line across, here it touches once, and then every other time, how many times is it touching? Twice. So let me actually draw a vertical line here. There are 2 intersections between my vertical line and this graph, right here and right here. Is that a function? No. This is the visual equivalent of having the point, let's call it 310 and 3, -2. I don't know. Okay? The x value shows up more than once, right? So this is the graphical representation of what we were just doing above. Jen?
Wouldn't that, since they're right above each other, wouldn't that be 310 and 3 -10?
Yeah, probably. I just made up points. So you're right. Yeah, it's symmetrical. So what I want you guys to do is do these 2 squiggly lines. Are they functions? And I'll give you a hint. One is and one isn't. So you should have done your vertical line test across this one. Does it ever touch more than once? No. Remember, something that students a lot of times get confused. The axis is not part of the function. It's just this squiggly line. So as I'm dragging my vertical line across it, how many times is it touching there? Once. How about here? How about there? How about there? How about there? So is this one a function? Yes. Okay. So then what about this guy right here? My vertical line. So then that one's a function. So then this one, it's kind of a skinny one. But if I did a vertical line this way, how many times does it actually touch? 4. Here, 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 and here. So is that a function? No. So last week when I gave you just a straight up and down vertical line, I said that that was not a function and we put it on the back of our function families packet. Does anybody know why it would not be considered a function? Yeah, so if I'm drawing my vertical line, dragging my vertical line all the way across, right here, it's touching my vertical line at an infinite number of places, right? So it doesn't pass the vertical line test. So that's why vertical lines are not functions. Okay. Another way to look at this is that vertical lines, this is the same x value for infinity, going up and down. So it always repeats. So it never has one single y value. Okay? Make sense? So the only other thing that I want to kind of go over with you guys. So if I give you 3 points on a coordinate plane like this, and then I want you to list the elements of the domain and list the elements of the range, how can we figure that out? Rose. Perfect. So we look at the x-axis and list all of the points on the domain, and then we look at the y-axis and we list all of the points in the range. something that I do that kind of helps so that you don't get stuff confused is I actually write the coordinates of each of these. So this first point right here is at -1, +1. This second point is at +1, +4. 2 or 4, what, I don't know. This is because this is a handwritten graph, it's not as good. It'll be more clear. And then this one is at 3, -1. So what are my 3 elements in the domain, guys? -1, 1, and 3. And you just have to list them. What are my range elements? Perfect. Does that make sense? That's all you have to do. Okay? So on your homework, you have, I think there's 8 graphs on here total, and then I ask you the same questions for each of them. So let's look at number 1. This is a quadratic function, and I first ask you to determine the range, or sorry, the domain. So the domain are the x values that are listed on the graph. Now these lines, or the arrows on this, mean that the graph is going on for how long? Forever. And actually with a quadratic, it's opening out forever and ever and ever. So the question is, will all x values eventually be listed?
Yes.
If it's opening out forever and ever and ever. Yeah.
No, as it starts above 0.
Those are y values though. X values are going left and right. So all x values on a graph like this will eventually be listed. We call that all real numbers. There is a symbol for all real numbers. It's like a block R. Okay? So if you're from left to right, your graph goes on forever, your domain is all real numbers. So then Jen said something really interesting. She said, but it's above 0 right here, right? Is that the domain or the range? That's the range because it means going up and down, right? So your range is your y values. So we would say y. And it is touching, it looks like, I would say that's at 1. And is there a point actually on 1? Yeah, so this would be greater than or equal to 1. So why is that? We use the letter y because the range means y values, right? 1 is the lowest point. All y values from now on are above or equal to the point 1. This is super tricky. We will go over it some more tomorrow, but I want you guys to try it on your own first, okay? Is this one a function?
Yes.
Yes, so you would circle yes. And then this is the part that I really wanted to go over with you guys. Where is the domain of the graph increasing? So it says domain, which means x's or y's? X's. So which x values, so we're going to use the letter x. For which values is the graph increasing?
0 and higher.
0 and higher. So we would say x greater than or equal to 0. Thank you. Because for all x values bigger than 0, as we go to the right, the graph is increasing. Does that make sense? So then the question is, where's the domain of the graph decreasing? Remember, we read graphs from left to right. So where is it going down?
Less than or equal to 0.
Everything that is less than or equal to 0. So still x's less than or equal to 0. Okay? This is tricky because when we're looking at it, the arrow is going up, but remember we read graphs from left to right. Okay? This concept is challenging. On the homework, I want you guys to attempt all of these. I want you to have something written on all of them. There's only 8 of them. Tomorrow, I promise, we will go over any of the ones that you have a question on. But it's valuable for you to try on your own, because I think you might surprise yourself. Sound good? Okay, so that's it.